Section 4 of Familiar Letters on Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Peter Yearsley. Familiar Letters on Chemistry by Justus Liebig. Letter 4. My dear Sir, one of the most influential causes of improvement in the social condition of mankind is that spirit of enterprise which induces men of capital to adopt and carry out suggestions for the improvement of machinery, the creation of new articles of commerce, or the cheaper production of those already in demand; and we cannot but admire the energy with which such men devote their talents, their time, and their wealth to realize the benefits of the discoveries and inventions of science. For even when these are expended upon objects wholly incapable of realization, nay, even when the idea which first gave the impulse proves in the end to be altogether impracticable or absurd, immediate good to the community generally ensues. Some useful and perhaps unlooked-for result flows directly or springs ultimately from exertions frustrated in their main design. Thus it is also in the pursuit of science. Theories lead to experiments and investigations, and he who investigates will scarcely ever fail of being rewarded by discoveries. It may be, indeed, the theory sought to be established is entirely unfounded in nature, but while searching in a right spirit for one thing, the inquirer may be rewarded by finding others far more valuable than those which he sought. At the present moment electromagnetism, as a moving power, is engaging great attention and study. Wonders are expected from its application to this purpose. According to the sanguine expectations of many persons, it will shortly be employed to put into motion every kind of machinery, and amongst other things it will be applied to impel the carriages of railroads, and this at so small a cost that expense will no longer be matter of consideration. England is to lose her superiority as a manufacturing country, inasmuch as her vast store of coals will no longer avail her as an economical source of motive power. We, say the German cultivators of this science, have cheap zinc, and how small a quantity of this metal is required to turn a lathe, and consequently to give motion to any kind of machinery. Such expectations may be very attractive, and yet they are altogether illusory. They will not bear the test of a few simple calculations, and these our friends have not troubled themselves to institute. With a simple flame of spirits of wine, under a proper vessel containing boiling water, a small carriage of 200 to 300 pounds weight can be put into motion, or a weight of 80 to 100 pounds may be raised to a height of 20 feet. The same effects may be produced by dissolving zinc in dilute sulphuric acid in a certain apparatus. This is certainly an astonishing and highly interesting discovery, but the question to be determined is, which of the two processes is the least expensive? In order to answer this question, and to judge correctly of the hopes entertained from this discovery, let me remind you of what chemists denominate equivalents. These are certain unalterable ratios of effects which are proportionate to each other, and may therefore be expressed in numbers. Thus, if we require 8 pounds of oxygen to produce a certain effect, and we wish to employ chlorine for the same effect, we must employ neither more nor less than 35½ pounds weight. In the same manner 6 pounds weight of coal are equivalent to 32 pounds weight of zinc. The numbers representing chemical equivalents express very general ratios of effects, comprehending for all bodies all the actions they are capable of producing. If zinc be combined in a certain manner with another metal, and submitted to the action of dilute sulphuric acid, it is dissolved in the form of an oxide. It is in fact burned at the expense of the oxygen contained in the fluid. A consequence of this action is the production of an electric current, which, if conducted through a wire, renders it magnetic. In thus effecting the solution of a pound weight, for example, of zinc, we obtain a definite amount of force, adequate to raise a given weight 1 inch. and to keep it suspended, and the amount of weight it will be capable of suspending will be the greater the more rapidly the zinc is dissolved. By alternately interrupting and renewing the contact of the zinc with the acid, and by very simple mechanical arrangements, we can give to the iron an upward and downward or a horizontal motion, thus producing the conditions essential to the motion of any machinery. This moving force is produced by the oxidation of the zinc, and setting aside the name given to the force in this case, we know that it can be produced in another manner. If we burn the zinc under the boiler of a steam engine, consequently in the oxygen of the air instead of the galvanic pile, we should produce steam, and by it a certain amount of force. If we should assume, which however is not proved, that the quantity of force is unequal in these cases, that, for instance, we had obtained double or triple the amount in the galvanic pile, or that in this mode of generating force less loss is sustained, we must still recollect the equivalents of zinc and coal, and make these elements of our calculation. According to the experiments of Despretz, 6 pounds weight of zinc, in combining with oxygen, develops no more heat than 1 pound of coal. Consequently, under equal conditions, we can produce 6 times the amount of force with a pound of coal as with a pound of zinc. It is therefore obvious that it would be more advantageous to employ coal instead of zinc, even if the latter produced 4 times as much force in a galvanic pile as an equal weight of coal by its combustion under a boiler. Indeed, it is highly probable that if we burn under the boiler of a steam engine the quantity of coal required for smelting the zinc from its ores, we shall produce far more force than the whole of the zinc so obtained could originate in any form of apparatus whatever. Heat, electricity, and magnetism have a similar relation to each other as the chemical equivalents of coal, zinc, and oxygen. By a certain measure of electricity we produce a corresponding proportion of heat or of magnetic power. We obtain that electricity by chemical affinity, which in one shape produces heat, in another electricity or magnetism. A certain amount of affinity produces an equivalent of electricity, in the same manner as, on the other hand, we decompose equivalents of chemical compounds by a definite measure of electricity. The magnetic force of the pile is therefore limited to the extent of the chemical affinity, and in the case before us is obtained by the combination of the zinc and sulphuric acid. In the combustion of coal the heat results from, and is measured by, the affinity of the oxygen of the atmosphere for that substance. It is true that with a very small expense of zinc we can make an iron wire a magnet capable of sustaining 1,000 pounds weight of iron. Let us not allow ourselves to be misled by this. Such a magnet could not raise a single pound weight of iron 2 inches, and therefore could not impart motion. The magnet acts like a rock, which while at rest presses with a weight of 1,000 pounds upon a basis. It is like an enclosed lake, without an outlet and without a fall. But it may be said we have, by mechanical arrangements, given it an outlet and a fall. True, and this must be regarded as a great triumph of mechanics, and I believe it is susceptible of further improvements, by which greater force may be obtained. But with every conceivable advantage of mechanism, no one will dispute that 1 pound of coal, under the boiler of a steam engine, will give motion to a mass several hundred times greater than a pound of zinc in the galvanic pile. Our experience of the employment of electromagnetism as a motory power is, however, too recent to enable us to foresee the ultimate results of contrivances to apply it, and therefore those who have devoted themselves to solve the problem of its application should not be discouraged, inasmuch as it would undoubtedly be a most important achievement to supersede the steam engine, and thus escape the danger of railroads, even at double their expense. Professor Weber of Göttingen has thrown out a suggestion that if a contrivance could be devised to enable us to convert at will the wheels of the steam carriage into magnets, we should be enabled to ascend and descend acclivities with great facility. This notion may ultimately be to a certain extent realized. The employment of the galvanic pile as a motory power, however,